Okay, so we'll go to 9E.2, and we've got here, if we flip the page, page 36, we're just extending what we've done here but for an ellipsoid. And the only difference really for making an ellipsoid is that the coefficient of the x term and the coefficient of the y term will be different. So we'll get into our example. We have a footballer running laps of the oval. Okay, his position is given by this equation. So we have x of t is 85 cos w t, and y of t is 70 sin w t. All right, show that the Cartesian equation of the footballer's path is this. So we're going to start with x of t. So we have x of t equals 85 on cos wt. And what I'm going to do is I'm going to divide both sides by 85. So I'll have x of t on top of 85 equals cos of wt. And I'll do the same for the sine. I'll divide both of them by 70. So I'll have y of t on top of 70 equals sine of wt. And then we know that cos squared of theta plus sine squared of theta is 1. So the x squared, x of t squared on top of 85 plus y of t squared on top of 70 is 1. So that's the Cartesian equation that describes it. That's the equation of an ellipsoid. And having done a fair bit of these in the methods folio, we know we have the major axes and the minor axes. Okay, so that's part A. Part B, given that it takes the footballer 60 seconds to run a whole lap, determine the value of W. Okay, so just from the previous page, we have 2 pi on W is equal to period. Now we're told we have a period of 60 seconds, so 2 pi on W equals 60. We're solving through for W. 2 pi on 60 is W, which is the same as pi on 30. That's part B. And then part C, find the position, velocity and speed of the footballer after 20 seconds. So position is just when time is 20, what's the position going to be? So we're putting in here for W, we've got pi on 30. Pi on 30. All right, so when time is 20, we will have 85 cos 20 on 30 times t. 20 on 30 times pi, sorry. And sine will be 70, 20 on 30 pi. Now that's 2 on 3 pi, isn't it? And so that's going to keep popping up. So 2 pi on 3 is here. And so sine of 2 pi on 3 is root 3 on 2. Cos of 2 pi on 3 is half. Negative half, sorry. Alright, so we can evaluate those now. 85 times negative half, so the x component will be negative 40, and the sine component is going to be 70 root 3 on 2, which is 35 root 2. So the position then, when time is 20, x is minus 40, and the y value is 35 root 2. Alright, now again, you can just type all of that 20 on 30 into in here, put in the time is 20 there, evaluate that, we'll get minus 40. Okay, so that's the position. Velocity, so we need the velocity vector, and the velocity vector is the derivative of these, right? So the velocity vector then is going to be 85 times pi on 30. Now, cos goes to negative sign, so it's negative 85 pi on 30. Sine, and then we have pi on 30t. And 70 on 30 cos pi on 30t. Y. So that's the velocity vector, and then we're going to put in when time is 20. So again, that's going to become sine of 2 pi on 3, that's cos of 2 pi on 3, and then pi there. And so that will simplify to minus 85 on 30 pi sine 2.3 root 3 on 2. And here's 70 on 30. Pi positive 2.3 negative half. And we can simplify those a little bit, or just, it's pretty nasty, just mash it to 3 sig figs. What do we have? 85 on 30 pi times root 3 on 2. $7.708 minus 7.71, and for the y component, 17 on 30 pi times half, negative half, 3.66. Okay, so that's the velocity vector. Okay, find the position, velocity, and speed. Okay, so we have a position, we have its velocity, and then speed is just the magnitude of velocity, right? So speed is the square root.
Isn't speed RW?
Yes, except that's for circular motion. Yeah, yeah.
Because we've got two different R's, don't we?
Correct, yeah. Well done, good pick up. Yep. So we've got 7.71 squared plus 3.67 squared and the square root 72. 8.53. 54. And units, we've got meters per second. 8.5 is pretty quick. Almost a sprint. That's definitely a sprint. It's Usain Bolt pace.